So this problem is a little bit involved, just because of the numbers that they give us. So let's take a look at it. It says that a Ferris wheel with a radius of 8 meters makes 1 revolution every 10 seconds. Okay, good to know. When a passenger is at the top, essentially a diameter, not a radius, but a diameter above the ground, he releases a ball. How far from the point on the ground directly under the release point does the ball land? I'm looking at this thing, there's a lot of words in here, there's a couple different situations. I'm going to draw a picture. I have a Ferris wheel, a nice little Ferris wheel. It says that it has a radius of 8 meters. It also has 1 revolution every 10 seconds. So that is going to give me something about its velocity. It tells me how fast this point on this wheel has to travel a full circle. It also says in the second part of this, it says if we're at the very top above the ground, if we're at the very top above the ground and we release a ball, we want to know how far from this point, how far over does this ball land? And this ball is going to do a nice little parabolic fall to it. So this is actually a 2-part problem. First part deals with figuring out what is its velocity at this point. When we release the ball, we release it not from rest. We release it from rest compared to ourselves. But we are moving because we're at the top of this Ferris wheel. The Ferris wheel is constantly moving. We're going to have velocity all the way around this thing. So the ball is going to do some form of parabolic motion because it has initial velocity when we release it from our hand. It's just going to, we're going to try to drop it, but we have some initial velocity. So in my mind, this reminds me a lot of these problems where you have like an airplane releasing a bomb over a target. Yeah, it's the same general idea. However, we need to get that velocity. So let's figure this out. And actually, the part that gives us the information is it says 1 revolution every 10 seconds. Well, 1 revolution tells me how many angles it goes through. It goes through 2 pi radians. But that's still not the value I want. I want what is its arc length. How long does it take to do 1 full circle? And that actually is how we're going to solve it. 1 revolution means that we go 1 time around the circle. And we know that the path around a circle is 2 pi r. So 1 revolution is a path length of 2 pi r, the circumference of a circle. And we're going to do this in 10 seconds. So really what I'm going to want is s over t is going to give me my velocity. The time to go around the whole circumference divided, or the full circumference divided the time it goes around it will give me how fast I'm going around this. So 2 pi r divided by time is going to give me my velocity. This is going to be approximately equal to 6 times 8 divided by 10, or approximately equal to 4.8 meters per second. 4 times 8 is 48 divided by 10, or 6 times 8 is 48 divided by 10 is going to be 4.8. I approximated pi to be 3.143. Yeah, it's close enough. If I had to make a guess, I'd say that's probably closer to 5. Anyway, now that I have this case, I want to know how far does it land. I'm going into kinematic problems, so I actually have to solve 2 kinematic equations, figure out how long does it take to go to the ground. Well, I know that to go to the ground, y is equal to y naught plus v naught yt plus 1/2 at squared. It's acceleration in the y direction. The ground is at 0. I'm going to say positive x is in the left direction and positive y is in the up direction. So I'm at 0 at the ground. I start out at 2 times my radius up, second radius up. My initial velocity in the y direction is 0, and my initial gravity is minus g. So minus g times 1/2 t squared. Or 4r over g square rooted is going to give me my time. G is 10, 4, 8, and the square root will give me the square root of 4 times 8. 4 times 8 is 32, so square root of 3.2, which is approximately equal to 1.8 to 1.9 seconds. It's just a hair under 4, square root of 4, which would be 2. So I'm going to just say somewhere probably around 1.8, 1.9. Don't have a calculator on me, so I'm just doing this in my head. But I know that it takes 1.8 seconds to do this trip. So now I'm going to go and slide into my horizontal direction. In my horizontal direction, I know that I'm given x equals x naught plus v naught xt plus 1/2 axt squared. My final position is a distance d from the center. This was my original starting point right here, or my original 0, 0 point is right there. So d is equal to 0. I started at a position of 0 away from my origin in the x direction, plus my initial velocity, v naught x, which I solved over here before, this value right there, plus 1/2 ax squared times axt squared. My ax is 0. Oh, and I forgot a t there. So now I'm going to say distance is equal to 4.8 meters per second times my 1.8 seconds. This is going to be approximately equal to somewhere below 9. So 4.5, I would say this is approximately equal to 4.5 times 2. So I'm going to say that the correct answer, what it looks like, looks like it's approximately equal to 9 meters. So I'm going to say the correct answer is D, 9.1 meters. Just looking at all my approximations. I could actually solve this, and I'm going to do a check. Probably shouldn't have plugged in the square root of 4rg, and I probably should have left the 2 pi r squared over in this value. So let me actually resolve this. So d is equal to the velocity, 2 pi r over t, where t is the 10 seconds, times my time that I got, which is square root of 4r over g. All right, so this is going to be a little bit of a better way to do this. This is going to be 2 times 3.14 times 8 over 10 times the square root of 4 times 8 over 9.8, which is equal to 2 times 3.14 times 8 times 2, square root of 4 is 2, times 2 square root of 2 over 10 square root of 9.8. And this value will work out to be 9.1 meters. So this is the actual number that's doing to 2 digits. I put an extra digit in pi in there. But to 2-digit accuracy, this is the actual number we want to work out.